Hello everyone, welcome to part 2 of solving polynomial inequalities. There are two examples in this video. There are two totally different examples. So let's begin. So with problem A, we have x squared plus 5x is greater than or equal to 24. So if you watched the first video, I pointed out the fact that before you can do your number line test to solve the polynomial inequality here, you first have to set the problem up with factors on the left side and 0 on the right side. So first, let's start by getting 0 on the right side by bringing 24 over to the left side by subtracting. 24 minus 24 will give me 0. And then the next step would be to factor the left side. So I have x squared plus 5x minus 24. That's quadratic, so I can factor that into two linear factors. So I have x plus 8 and x minus 3 would be the correct factors for x squared plus 5x minus 24. Okay, so now I'm going to box this off because I'm going to be using this for the rest of the problem. All right, so again, remember the basic form here that you need to successfully use your method are factors on the left and 0 on the right. You need those two things to successfully use the method of the sign test to solve this inequality. Okay? So here we go. Let's clear this up a little bit. Step number 1. All right, so remember you want to get the zeros of the left side. So remember you bring down your factors, x plus 8, set it equal to 0, and x minus 3, set it equal to 0. So here we get x equals negative 8 and x equals positive 3. Step 2, set up a number line. All right, so you have those two numbers. Put them in order, and also include your infinity symbols because they may be useful. This line, label with an x because you have x values on that line. And on top of the line, remember you're going to put the sign of the y values. And in this case, the signs can be positive, negative, or 0, meaning no sign at all. Okay, so above the negative 8, we're going to put a 0, and 3, we're going to put 0, because those are the zeros of the function. That means that their y values are 0. Next, you have now, the line is broken up into 3 sections. So what you're going to do now is pick a test x value in each of those sections, like negative 9, how about 0 here, because it's somewhere in the middle. And then above 3 would be something like 4 or 5. The numbers that I chose are not the only number. You can choose any numbers in those segments. So any number would be correct, as long as you don't reuse the negative 8 and the 3. So don't reuse numbers. Now the next thing, you're going to plug those into the expression up here for x. And whatever you get, we're going to call them the y values. Okay? So now when you do that, so when you plug in negative 9, you get 12. When you plug in 0, you get negative 24. And when you plug in 4, you get, well, positive 12 again. Okay, so now what do I do with that? I go back to the top of the line, and I'm going to record the sign of those y values. So up here, I'm going to put a positive sign because the y value is positive 12. And then in the middle, I'm going to put a negative sign because the y value is negative 24, and here is positive 12. So now finally, I can actually write out my solution from that. So open brace, x. All right. Now, what do we write down? So it's all based upon this symbol here. Now, when you say greater than or equal to 0, that has two meanings. So greater than means positive values, because greater than 0 is like 1, 2, 3, 4, 5. So we're looking at where the function is positive, and the bottom part just means equal to 0. So on your number line, it would be helpful to first circle the symbols that correspond to that. So plus signs and zeros, positive and 0. Now the plus signs correspond to each of these sections, so you shade those in. And since we're including the 0 here, we're going to use a solid point, or it's a bracket. Infinity symbols always use parentheses. So the first part of my answer is simply negative infinity to negative 8 bracket. Now union, because there's a second interval in my solution, so we just union them together as one solid solution. All right, so going back up here, we are including this value here. So again, use a solid point, which also would be a bracket. Infinity symbols always get parentheses, and there's my second half of the solution. Bracket 3 to infinity, parentheses. All right, and there's the solution for the first problem. Let's take a look at the second problem. So in this problem, we have the factors x plus 3 times x plus 1 is less than or equal to negative 1. Now, it looks like it's factored, and the left side is factored in a sense, but we have one big problem, and the problem is this. It's not 0. So even though the left side is factored, you do not have the basic standard form for using this sign test method. So what you need to do is see if you can combine everything. So combining everything would simply mean bringing down x plus 3 and x plus 1 and adding that 1 to the left side. So by adding 1, now we have a 0. However, we have an issue on the left side now. So the left side is not completely factored. We have factors here, but then you have this oddball number next to it. That's not a factor if it's being added. Because remember, factors are multiplied. So since you're adding something to the factors, the entire left side is not factored. So what do? How about simplifying the expression here, x plus 3 times x plus 1? So we're going to FOIL that expression. So you get x times x is x squared. We get a 1x and a 3x is 4x. 1 times 3 is 3, plus 1 is less than or equal to 0. So now simplifying a little more, we get x squared plus 4x plus 4 is less than or equal to 0. Now see if you can factor that. That's with all the terms combined. And that factors nicely into x plus 2 times x plus 2. And now I can proceed because now I have my basic or standard form where you have everything is a factor on the left side and a 0 on the right. So now step 1, I get the zeros, which nice enough here, the zeros, there's only one of them since you have a repeat. X plus 2 equals 0 means x equals negative 2. Step 2, number line. It's not going to be much of a number line because we only have one number to place on there, along with negative infinity, positive infinity. Those are my x values. And then right on top of it, the sign of the y values. So we have negative 2 is a 0. And then all I have to do is test a number in this segment or interval and this segment or interval. So pick a number like x equals negative 3, negative 4. Over here, pick a number like x equals, how about 0? That fits nicely in there. So when I plug in x equals negative 3, I get 1. When I plug in 0, I get 4. And since they're both positive, I put plus signs on top of those segments. So now I can go to my solution because I have my sign test complete. Okay, so the symbol that we have here is less than or equal to 0. So less than 0 means negative only. And notice there's no negative signs on top of the number line. So there's nothing to circle for the negatives. So there's none here. However, I have equal to 0. And I have one spot where it's equal to 0. Now remember, because it's only one place or one value that's equal to 0, I'm not shading anything there. I'm just putting a solid dot. And that's the only thing I can fill in on my number line. So what's my solution? X equals a single number, -2. And that's it. There's no shading anywhere else because there are no negative regions of the function. That is it. So I hope you found these 2 example problems useful and helpful. I am the math musician. Please subscribe to my channel and check out my other videos. Some are math and some are music with me on the piano. Thanks for watching.